First question, it says write 0.45 as a fraction in its lowest terms. 0.45 is basically 45 over 100. We know 45 is 9 times 5 and 100 is 20 times 5. So that's going to be 9 over 20. Part B says write these fractions in order of size, starting with the smallest. So let's first convert them into like similar denominators. So I'm going to multiply the first fraction by 4. I'm going to multiply the second fraction by 2. Now this way, all of these fractions will have a denominator of 20. So now if we compare these, smallest is 7 over 20, which is 7 over 10. Next we have is 16 over 20, which is 4 over 5. And greatest is 17 over 20. Question 2 says complete the description of the symmetry for each shape. So now if you look at the first shape, we have 3 black triangles and 3 white triangles, which means if we draw lines of symmetry, this is 1, this is 2, and this is 3, which means we have 3 lines of symmetries. And for the rotational symmetry of order, if we rotate this object, what we can see is each time we rotate this, we will get the same triangle above. So that means it's going to have a rotational order of symmetry of 3, especially since there are 3 black and 3 white. So when we rotate it, we need to make sure that when the first black comes and the second and third, so every single time the black triangle comes, the shape is going to be the same. Then for this square, we have to find the lines of symmetry. As you can see, like if we add a line over here, it's not symmetrical. It's not symmetrical like this, neither like this, or the like according to the diagonal that's already drawn. So which means there's 0 lines of symmetry, which means there are 0 lines of symmetry. And for the rotational symmetry of order, if you look at this shape at this point, and if I move this shape to 180 degrees, so it's going to come back to again this point. So if you have this like, if I draw this over here, this is your 90-degree rotation. So now if you rotate it again, now what's going to happen is that your triangle is going to come back over here. So as you can see, when we rotate it at 180 degrees, the shape comes back to its original point. Since sum of angles for a square is 360, so we divide 360 by the rotation, which is 180, and that equals to 2. So that means rotational symmetry of order for this is going to be 2. Question 3 says a group of 60 students were each asked their favorite fruit. The results are shown in the table. Complete the pie chart to show the results. So they've drawn the portion for apple. So what we will do is we will find the angles for banana and orange. So for banana, it's going to be 25 over 60 times 360. The reason why we're multiplying by 360 is because we're trying to find the angle for bananas. And same for orange, we're going to do 15 over 60 times 360. So now if we solve this, the zeros get cancelled out. 6 ones are 6, 6 6 are 36. So we do 25 times 6, which is going to be 150 for this one. And over here, we'll do 15 times 6, which is going to be 90 degrees for this. So you'll use a protractor and you'll plot these angles on the pie chart. and then your bar chart results will be complete. Question 4 says write 64,785,491 correct to the nearest million. So which means we're going to focus on the digit 7. So since 7 is greater than 5, so that means 4 would get 1 added to it and would be 65 million. Part B says writing each number correct to one significant figure, estimate the value of this. So 67.8 is going to be 70. 49.5 will be 50 and 0.187 will be 0.2 square. So now if we solve this, 70 plus 50 is going to be 120. 120 divided by 0.2 square, which is going to be 0.04 over here. So move the decimal. So that's going to be 12000 divided by 4, which is 3,000. Umar and Jamil share $540 in the ratio 7:2. Work out Umar's share. So Umar is going to have 7 over 7 plus 2, which is the total of the share, times the money, which is 540. So that's 7 over 9. We know 9 ones are 9 and 9 60s are 7. 9 60s are 540. So 7 times 60, which is $420. Then it says increase 40 in the ratio 5:8. So what we will do is we'll write 40 over x equals to 5 over 8. Cross multiply 40 times 8 over 5. 5 ones are 5, 5 eights are 40. So 8 times 8 is 64. That is the value of x. The base of a cuboid is a square with side length 4 centimeters. The volume of the cuboid is 48 centimeter cube. On the grid, complete the accurate drawing of the net of the cuboid. The base is drawn for you. So if this is 4 by 4, and we know the volume is 48, so that means we're going to do 48 equals to 4 times 4 times the height. So 4 times 4 is 16 and 48 divided by 16 is 3. Which means the third measurement is going to be 3. So since it's a square, 4 over here, 4 over here. So now this distance is going to be 3 units. This is also going to be 3 since it's a cuboid. 3 and 3. So now since the bottom face is square, that means the top face is also going to be a square. So 1, 2, 3, 4 over here and 4 over here. So now if we connect this, these are the rectangular sides of the cuboid. And this is the rectangular one. And this is the square top. Question 7 says, a bag contains colored counters. A counter is taken from the bag at random. The table shows the probabilities of picking a counter of each color. Complete the table. So always remember that the probability of like all of the events happening at the same time is equal to 1, which means probability of blue is going to be 1 minus 0.15 minus 0.3 minus 0.42. And that's going to equal 0.13. Question 8 says work out 3 whole number 205 minus 1 whole number 304. So first we'll convert the mixed numbers into improper fractions. We start with multiplying 5 by 3 and then adding the result to 2. So 5 3s are 15 and 15 plus 2 is 17. So 17 over 5. Same with the other fraction. 4 times 1 is 4. 4 plus 3 is 7. 704. So now since we're subtracting unlike denominators, we need to make the denominators equal. So in order to do that, I'm going to multiply the first fraction by 4 and the second fraction by 5. So now what we'll have is 68 over 20 minus 35 over 20. So now that we have same denominators, we can subtract the numerators, and that gives us 33 over 20. Question 9 says the sketch shows the positions of 3 villages A, B, and C. A is due east of B. Use a ruler and compasses only. To complete the scale drawing of triangle ABC, use a scale of 1 centimeter to represent 1 kilometers. So they've already drawn the line AB, which if you measure is going to equal to 9 centimeters. So the other lengths are 8 and 5. So what you will do is, just remove that. What you will do is you will open your compass to 8 centimeters first, and then you will put the compass over here and draw an arc over here. And then you will open your compass to 5 centimeters, put your compass at A and draw another arc. So once you've done that, you will connect the points and that will give you the triangle. This will be 8 centimeters and this will be 5 centimeters. Then it says measure the bearing of C from B. So to measure the bearing of C from B, this is your point C. This is B, so this is your bearing. So to find the bearing of C from B, what we will do is we'll use a protractor. We'll put it over here and measure this angle, the colored angle, and that would give you the bearing. It's going to be something greater than 90 degrees, obviously. So yeah. Question 10 says write 270 as the product of its prime factors. So let's split 270. 270 is 27 times 10. You can start with any other factor as well. You can do 90 times 3 or 30 times 9. That's up to you. 27 is 9 times 3 and 9 is 3 times 3. Now 10 is 5 times 2. So 3, 5 and 2, all these 3 are prime numbers. So we can't further break them down. So 270 can be written as 2 times 3 cube times 5. This is the product of its prime factors. Find the highest common factor of 270 and 225. So we know that 270 is 2 times 3 cube times 5. So let's prime factorize 225 now. Question 10 says write 270 as the product of its prime factors. So let's split 270. 270 is 27 times 10. You can 225 is 25 times 9. 25 is 5 times 5 and 9 is 3 times 3. So now if we rewrite 225 as the product of its prime factors, that is 3 square times 5 square. So now the highest common factor of 270 and 225 is 3 square times 5, which is 9 times 5, and that is 45. You will always pick the common numbers. We're not picking 2 because there's no 2 in 225. And for 5, we're just picking 1 5 because between both the prime factors, only 1 5 is common, not 2 5s. Same applies for the 3s. There are only 2 3s common, not 3 3s. Question 11, it's asking to solve the simultaneous equation. So what we will do is we will use the elimination method. And in order to do the elimination method, we will first begin with deciding which variable we want to eliminate. I'm going to eliminate y. You can also eliminate x. It's completely up to you. There's no restriction. So the variable chosen to eliminate, we need to make sure that the coefficients are equal for that variable in both the equations. So now if you look at the coefficient of y in equation 1 and in equation 2, we can see that it's different. It's 2 and 3. So that means we need to make the coefficients equal first. And that can be done by multiplying the first equation by 3 and the second equation by 2. So we'll multiply 3 with 5x, then 3 with 2y, and then with 7. So that leaves us with 15x plus 6y equals to 21. Now we're going to multiply 2 with the second equation. So that's going to be 2 times 2x plus 2 times negative 3y equals to 2 times 18. So that's 4x minus 6y equals to 36. So now as you can see in the new equations, both the coefficients of y are equal, which means we can further solve this. So now next thing we need to look at is the sign for the variable y. If the signs are same, that means we will subtract the equations. If the signs are opposite, we add them. In this case, the signs are opposite. One is positive and one is negative, which means we will add the equations. So 15x plus 4x is 19x. 6y minus 6y is 0. 21 plus 36 is 57. So 19x equals to 57. X is 57 divided by 19, which is going to equal to 3. So now since x is 3, we will put x in either of these equations and find the corresponding y value. So if I choose the first one, 5 times 3 plus 2y equals to 7. 15 plus 2y is 7. 2y equals to 7 minus 15, which is equal to negative 8. So y is negative 8 over 2. And that is negative 4. So when x is 3, y is negative 4. Question 12 says, Lara goes for a cycle ride. The distance time graph shows her journey. Calculate Lara's average speed in kilometers per hour for the whole journey. So now if you look at the graph, this is your distance value and this is your time value. So distance over here is 24 and time is 30 minutes. So since we have to find the average speed is basically distance over time taken. So that's going to be 24 divided by 30. But since they're asking us the time in kilometers per hour, so let's convert the time into hours first. So we know that 1 hour is 60 minutes. 1 hour is 60 minutes. So 1 minute is going to be 1 over 60 hours. So for 30 minutes, we'll do 30 over 60, which is 1 over 2. So 24 divided by 1 over 2 is basically 24 times 2. And that is 48 kilometers per hour. A car travels at a constant speed of 10 meters per second for 80 seconds. It then decelerates at a constant rate of 0.5 meters per second square until it stops. On the grid, draw the speed time graph for this journey. So first, it's at a constant speed of 10 meters per second for 80 seconds. That's going to be till here. And then it decelerates at a constant rate of 0.5 meters per second square. So we need to find the final time. So what we'll do is 0.5, negative 0.5, because it's deceleration, equals to your speed is going from 10 to 0. And at 10, your time is 80 minus x. So it's going to be negative 0.5 equals to 10 over 80 minus x. Cross multiply 80 minus x times negative 1 over 2. I'm just rewriting the decimal as a fraction. So that's going to be negative 40 plus x over 2 equals to 10. X over 2 is 10 plus 40. And x is 50 times 2, which is 100. So that means your graph will end over here. Write 0.000053 as a standard form. So what we will do is we will move the decimal 1, 2, 3, 4, 5 places to the right. That's going to be 5.3 times 10 to the power of negative 5. Then evaluate 1.5 times 10 to the power of 14 times 8 times 10 to the power of 6. Give your answer in standard form. So what we'll do is, I'm going to combine the 1.5 times 8 and 10 to the power 14 to 10 to the power of 6. Now 1.5 times 8 is basically 0.4, and that is going to be 12. Now, whenever we have similar bases being multiplied, which in this case is 10, we add the powers. So it's going to be 14 plus 6, which is 12 times 10 to the power of 20. Now, since it says standard form, so it's going to be 1.2 times 10 to the power of 21. If a path is measured as 62 meters, correct to the nearest meter. Write down the upper bound for the length of the path. So since the degree of accuracy is nearest meter, so we will divide 1 by 2, which is 0.5. And upper bound will be 62 plus 0.5, which is 62.5 meters. Then it says, the mass of a bag of peanuts is 80 grams, correct to the nearest 10 grams. Calculate the lower bound for the mass of 5 of these bags of peanuts. So what we will do is, we'll first find the degree of accuracy by dividing 10 grams by 2. So 10 divided by 2 is going to be 5. So now for the lower bound, I'm going to subtract 5 from 80, which is 75 grams. So since they want the lower bound for the mass of 5 of these bags, you multiply 75 by 5, and that is 375. That is your lower bound.